In this video, we want to integrate dx over 1 plus x squared quantity squared. The way we're going to do this is by making a trig substitution. So we'll let x equal tangent theta. So dx is secant squared theta. So we're going to replace the top with secant squared times d theta. The denominator just becomes 1 plus tangent squared quantity squared. And we know 1 plus tangent squared is just secant squared. So plug that in. And so we have secant squared over secant squared squared. So the secant squared from the top is going to cancel. And so we have just d theta over secant squared, which secant squared is just 1 over cosine squared. So that comes on the top as cosine squared. Now we're going to use a trig identity. Cosine squared is 1 plus cosine 2 theta over 2. So we split this up into two fractions, and then we integrate. So that's 1/2 theta plus sine 2 theta over 4 plus c. And recall, we had let x equal tangent theta. So if you look at a right triangle, let's call this theta. Tangent, think of that as just x over 1. That's opposite over adjacent. Pythagorean theorem says this is x squared plus 1. But, so now we go back into the equation. We know theta here. Well, if x is tangent theta, to solve for theta, you just do the inverse tangent. So that's inverse tangent x. Sine 2 theta is 2 sine theta times cosine theta, which sine theta is opposite over hypotenuse. That's x over square root of 1 plus x squared. Cosine theta is adjacent over hypotenuse. That is 1 over square root of 1 plus x squared. So bring it in together. So we have 1/2 theta, which is 1/2 inverse tangent x, plus, and then here we have sine 2 theta. Sine 2 theta is, I guess we can do an extra step here, is 2x over 1 plus x squared. So that's this thing over here. And then we just need to divide it by 4. Plus a constant. The 2 is going to cancel with the 4. That becomes a 2. And then I can factor out a 1/2 from both of these and get this as our final answer.